Hello, and welcome to Sleep with Science, where your mind can rest and your curiosity can wander. Here, science doesn't shout, it flows softly, like moonlight, across still water. Every night, we drift through quiet questions and cosmic stories, letting the universe speak in a slower language. Let's begin. Tonight, let's look up together at the night sky. Far above the city lights, beyond the clouds, our constant companion drifts, a gentle presence in the darkness. The moon. It's easy to take it for granted, isn't it? To see it as simply a backdrop to our lives, a silver disk hanging silently in the distance. But the truth is, the moon's story is deeply entwined with our own. It has shaped everything from our planet's climate to the rhythms of life itself. Imagine, for a moment, looking up and seeing nothing. Well, not nothing. The stars would still be there, shimmering faintly in the dark. But the moon, that familiar, glowing orb that has graced our skies for eons, gone. No full moon casting long shadows, no crescent hanging like a delicate smile, no lunar eclipses turning the night sky a dramatic crimson, just empty space where something essential used to be. It's hard to truly grasp the magnitude of the moon's influence. We're so accustomed to its presence that we rarely consider what life would be like without it. It sits up there so peacefully, so quietly, not demanding attention like the sun, yet behind that serene facade lies a force that has shaped our world in ways we are only just beginning to fully understand. So, tonight, let's try to take a fresh look at this ancient companion. Let's trace its history, explore its influence, and maybe even gain a new appreciation for its quiet yet profound role in the universe. Get comfortable, breathe deeply, and let's wander together into the gentle light of the moon and what is. Our moon, in cosmic terms, it's a remarkably large natural satellite circling our planet in an elliptical orbit. About a quarter of the Earth's diameter, it's far bigger relative to its host planet than most moons in our solar system. It's a scarred and cratered world, bearing witness to a tumultuous past, a surface devoid of air, water, or any signs of life, yet teeming with secrets about the early days of our solar system. But how did it even get there? The most widely accepted theory, and it's a spectacular one, is the giant impact hypothesis. Roughly 4.5 billion years ago, a Mars-sized object, often called they, collided with the early Earth. The impact was cataclysmic, vaporizing rock and sending debris swirling into space. Over time, gravity pulled this debris together, and it coalesced into the moon. Our moon is, in essence, a piece of Earth, forged in a cosmic collision of unimaginable scale. And from that violent beginning emerged a relationship that has defined our planet ever since. From our point of view, the moon is more than just a satellite. It's a constant presence, a familiar face in the ever-changing panorama of the night sky. It doesn't judge, it doesn't demand. It simply exists, circling our world in a predictable dance. Since the dawn of humanity, people have looked up at the moon and found meaning. It has been a timekeeper, marking the passage of days and months. It has been a guide, lighting paths through darkness. It has been a muse, inspiring poets, artists, and dreamers. It has been a symbol of hope, transformation, and the enduring mysteries of the universe. Consider the lunar phases. From the dark mystery of the new moon to the luminous fullness that bathes the world in silver light. The moon cycles through these shapes in a constant, reliable rhythm. Each phase has its own distinct character. The sliver of a crescent moon, a fragile promise of light to come. The half moon, a balanced blend of shadow and illumination. The gibbous moon, a swelling orb brimming with potential. And of course, the full moon, a celestial beacon that seems to hold the entire night sky in its thrall. These phases have captivated us for millennia, shaping our calendars, our rituals, and our very sense of time. And then there's the magic of moonlight. On clear nights, the full moon transforms the world. Colors fade into monochrome. Shadows lengthen and dance. The moon's light isn't harsh or demanding. It's soft and diffused, casting a gentle glow that invites reflection and contemplation. Think of a walk on a moonlit beach. The waves whisper secrets as they roll onto the shore. The sand shimmers with silver light, and the air is filled with a sense of peace and tranquility. Or imagine sitting by a campfire on a moonless night, the stars blazing with unparalleled brilliance. The darkness is profound, the silence intense, and the world feels both mysterious and intimate. Both are needed. Both are important. The moon's influence goes far beyond aesthetics. Its gravity tugs at our oceans, creating the tides that shape coastlines, mix nutrients, and provide habitat for countless marine species. And the moon has quietly stabilized Earth's axial tilt, helping our planet avoid drastic climate swings and maintaining a habitable environment for billions of years. It is more than just a passive observer. It is an active player in the drama of life on Earth. It is a silent guardian, keeping watch over our world from its perch in the sky. It is a constant companion, a friend in the darkness, a source of inspiration, and a reminder of the vast and beautiful universe we call home. And what about future connections? As we venture further into space, the moon beckons, not as a destination, but as a stepping stone, a place to test new technologies, to build sustainable outposts, and to prepare for journeys to Mars and beyond. The moon story is far from over. It's a story that continues to unfold with each passing day, with each new discovery, and with each upward gaze. It's a story that connects us to the past, grounds us in the present, and inspires us toward the future. Imagine Earth adrift, a cosmic sailboat without a keel. Our steady companion, the moon, vanished. The first thing you might notice: the silence. Oh, the stars would still glimmer, and the Milky Way would arch across the sky like a river of diamonds. But the familiar silver disk, our nightlight, our celestial muse, simply gone. Where once the moon hung, a comforting presence, now a void, a space where something deeply familiar should be. Since time immemorial, humans have looked at the moon and found comfort, solace, inspiration. Myths were built around it, calendars shaped by it, tides guided by it. Without it, a piece of ourselves would be missing. But the absence of the moon would be far more than a simple psychological shift. It would fundamentally alter the very fabric of our planet, creating a world both alien and precarious. Think of Earth's tilt, that gentle 23.5-degree angle that gives us our seasons. We can thank the moon for keeping it relatively stable. Without it, Earth's axis would wobble wildly, like a spinning top, losing momentum. The consequences: catastrophic climate swings. Imagine summers so scorching they'd boil the oceans, winters so frigid they'd freeze the very air. Forget predictable, growing seasons. Agriculture would become an exercise in futility. Entire ecosystems would collapse as habitats shifted and vanished. A constant global climate roulette. Then there are the tides, that rhythmic dance of the oceans ebbing and flowing under the moon's gravitational sway. Without the moon, the tides would be reduced to mere whispers, driven solely by the sun. They'd still exist, yes, but they would be a shadow of their former selves. Why does this matter? Well, those stronger lunar tides have played a pivotal role in the very origins of life. Picture early Earth, billions of years ago. Primitive organisms clinging to the edges of the sea. Tidal pools, those shallow, sun-warmed puddles left behind by the retreating tide, were nature's test tubes. A primordial soup, rich in minerals and organic molecules, concentrating and reacting in each cycle. The ebb and flow providing the perfect conditions for life to begin. Without the moon, those tidal pools might never have formed, or at least not in the same way. Life might still have emerged eventually, but perhaps far more slowly, along a different path. And even after life took hold, tides continued to influence it. Marine animals evolved to feed, migrate, and reproduce in sync with tidal rhythms. Coral spawning events, for instance, often timed to lunar cycles. Take away the moon, and an entire ecological choreography would fall apart. Think, too, about timekeeping. For millennia, humans tracked time by the moon's phases. A complete lunar cycle, new moon to full and back again, conveniently close to a calendar month. It regulated agriculture, rituals, travel. Without it, timekeeping would be far trickier, forcing us to rely on the more subtle movements of the sun and stars. The moon also shapes our nights. Before electric lights, the moon was our only real source of illumination after the sun dipped below the horizon. Moonlight guided travelers, aided hunters, and illuminated our world, driving the development and nature of nocturnal activities. No silver light bathing fields, forests, and faces. The night would be far more complete in its darkness, colder, more alone. Even more subtly, the moon has been gradually slowing Earth's rotation through tidal friction. When Earth was young, a day might have lasted just a few hours. The moon's gravitational tug stretched that out to the 24-hour day we know and love. Without the moon, Earth might still be spinning much faster with much shorter days. Imagine living on a planet where the sun rises and sets every 6 hours. Our internal clocks, our circadian rhythms, would have developed in a completely different way. Everything from metabolism to sleep to the very way we experience time could be alien. Some planetary scientists even believe that without the moon's moderating influence, Earth might be a less stable environment overall, not just in climate, but in plate tectonics, magnetic field generation, and even core cooling. While those ideas are still debated, the general consensus is that the moon is a major reason Earth has remained geologically and atmospherically active, and therefore habitable for billions of years. Take away the moon, and that moderating presence dissipates. But there's more. There's also the more practical loss of the moon. No werewolves, no midnight transformations. Even more practically, the night would be much darker. It's hard to overstate how much moonlight matters when you don't have streetlights, flashlights, or glowing screens. Remove the moonlight, and entire mythologies unravel. No lunar calendars, no moon festivals, and no werewolves. It's been a silent architect, a planetary partner, and a backstage manager, making sure the show runs smoothly. In its absence, the stage darkens. So, yes, Earth would still exist without the moon, but it would be a wilder, more chaotic, less predictable place. A place where the delicate balance that has allowed life to flourish for billions of years, teetered precariously on the edge. A less friendly world, a less habitable world, a world without its familiar silent guide, drifting alone in the cosmos. A world where the night felt longer and the sky felt emptier. Of course, our moon doesn't just light the way or gently tug the oceans. One of its most crucial contributions is stabilizing Earth's axial tilt. Think of it like this: Earth spins on its axis, an imaginary line running from the North Pole to the South Pole. This axis isn't perfectly straight up and down. It's tilted at an angle of about 23.5 degrees. And this seemingly small tilt is the reason we experience seasons. As Earth orbits the Sun, different parts of the planet lean towards or away from our star. When the northern hemisphere leans in, we get summer. When it leans away, it's winter. The southern hemisphere experiences the opposite. It's a simple but elegant system, and it works because Earth's axial tilt has remained relatively stable for millions of years. But what if that tilt started to wobble? It starts to lean and wobble, its angle shifting unpredictably. That's what Earth would be like without the moon. The Sun's gravity, along with the gravitational forces of other planets, like Jupiter, exerts a constant pull on Earth. These forces try to tug our planet off its axis, causing it to wobble or precesses. Now, this precession does happen even with the moon. It's a slow, gradual wobble that takes about 26,000 years to complete one cycle. But without the moon acting as a stabilizing force, this wobble could become much more extreme. Scientists estimate that without the moon, Earth's axial tilt could vary by as much as tens of degrees over relatively short periods. Geologically speaking, some models suggest it could range from nearly 0 to over 60 degrees. 0 degrees would mean no seasons at all. The sun would always shine directly on the equator, creating perpetual spring-like conditions year-round. While that might sound pleasant, it would also disrupt weather patterns and ocean currents, leading to widespread climate changes. A tilt of 60 degrees would be far more dramatic. The poles would point almost directly at the sun during summer, leading to extremely long days and scorching temperatures. During winter, they would be plunged into darkness for months on end, resulting in frigid, unending nights. Imagine what this would do to life on Earth. Plants and animals are adapted to specific seasonal cycles. They know when to bloom, when to migrate, when to hibernate. But with a wildly fluctuating axial tilt, those cycles would become unpredictable. Species would struggle to adapt to the extreme temperature swings and changes in daylight hours. Many would go extinct. Even the oceans would be affected. Ocean currents are driven by temperature differences and wind patterns, both of which are influenced by Earth's axial tilt. With an unstable tilt, ocean currents could shift dramatically, disrupting marine ecosystems and altering weather patterns across the globe. It is a complex scenario that comes down to a delicate balance. A stable axial tilt allows for predictable seasons, moderate temperature variations, and relatively stable climate patterns. A wobbling tilt leads to extreme climate shifts, ecological chaos, and potential mass extinctions. While scientists are still refining their models, most agree that the moon has played a crucial role in maintaining Earth's long-term climate stability. Consider Mars. Our red neighbor also has an axial tilt, roughly similar to Earth, but Mars doesn't have a large moon to stabilize it. Instead, it has two tiny moons, Phobos and Deimos, which exert very little gravitational influence. As a result, Mars' axial tilt is thought to have varied significantly over billions of years. And this may help explain why Mars transitioned from a warmer, wetter planet with liquid water on its surface to the cold, dry desert we see today. Climate stability is critical for the emergence and evolution of life. Life needs time to adapt to its environment and to gradually evolve new traits. A planet that experiences constant climate upheavals isn't conducive to that process. The moon has provided Earth with that stability. Its steady gravitational influence has acted as a buffer against the gravitational tugs of other planets, keeping our axial tilt within a relatively narrow range and allowing life to flourish. So, the next time you look up at the moon, consider it a cosmic stabilizer and a silent guardian of our planet's climate. Its quiet presence in the night sky has helped create a world where seasons come and go with predictable regularity, where ecosystems thrive, and where life in all its wondrous forms has been given the chance to evolve and flourish. Let's turn our attention now to the tides, that mesmerizing dance of the oceans. The rise and fall that shapes coastlines and has, perhaps, shaped the very history of life on our planet. These aren't just pretty undulations of water. They are a powerful testament to the moon's subtle but persistent influence. They are an age-old rhythm of the sea. The moon, that silent sentry in the night sky, is the primary conductor of this oceanic symphony, its gravity reaching across the vast expanse of space that tugs at Earth's waters, creating the rhythmic swells we know as tides. While the sun also contributes, its influence is less pronounced, a distant second fiddle to the moon's lead. To truly appreciate the moon's role, imagine the Earth without it. Our planet would still have tides, of course, but they would be a mere shadow of what we see today. Driven primarily by the sun, they'd be about a third of the size. The gentle lapping of waves against the shore would become a whisper, and the dynamic energy of the intertidal zone would diminish. Those stronger lunar tides are an important influence to the history of life on this planet. Now, rewind the clock billions of years. Picture early Earth, a world of fiery volcanoes and simmering oceans. There was no verdant land to see, no birdsong in the air, just water, rock, and a restless atmosphere. In this primordial soup, life was stirring, experimenting with different forms, struggling to find a foothold. And at the edge of the sea, between the land and water, lay a unique environment, the tidal zone. Tidal pools, those shallow, sun-warmed pockets left behind as the tide retreated, were nature's chemistry labs. In these shifting microworlds, compounds could concentrate, dry out, react, and then be replenished by the next wave. Think of it as a continuous cycle of creation and renewal, powered by the rhythmic pull of the moon. It's in those tiny, dynamic environments that the first complex molecules may have assembled into something resembling life. In the push and pull of the tides, in the gentle washing and drying of those ancient pools, life might have found its spark. It is even theorized by some that life may have begun, or at least gained momentum, in the gentle back and forth rhythm of the tides. Without the moon's influence, these tidal zones would have been far less dynamic. The weaker solar tides would have created smaller, less frequently inundated pools. The chemical reactions needed to kickstart life might never have occurred, or at least not in the same way. Imagine an ancient microbial mat clinging to a sun-baked rock. As the tide comes in, it's submerged, bathed in nutrient-rich water. When the tide recedes, it's exposed to the air and sun, its molecules reacting and bonding in the warmth. This cycle, repeated day after day, shapes the mat, influencing its growth and diversity. And this isn't just ancient history. The tides continue to shape life on Earth today. Marine animals have evolved intricate behaviors synchronized with the tides. Many creatures time their feeding, migration, and reproduction to the lunar cycle. Consider the fiddler crab scurrying across the mudflats as the tide recedes, its oversized claw waving like a tiny semaphore. Or the grunion, those small silvery fish that famously ride the high tide onto sandy beaches to lay their eggs under the moonlit sky. Coral reefs, the vibrant underwater cities of the ocean, often engage in mass spawning events timed with lunar cycles. These creatures, and countless others, have become masters of the tidal rhythm. They have evolved to anticipate the ebb and flow of the sea, to harness its energy, and to thrive in its dynamic embrace. Remove the moon, weaken the tides, and this delicate ecological choreography would be disrupted. Many species would struggle to adapt, and entire ecosystems could unravel. The moon's influence extends beyond biology, shaping coastlines and influencing weather patterns. Strong lunar tides scour the shores, sculpting cliffs, building sandbars, and creating intricate wetland ecosystems. They also help to mix ocean waters, distributing nutrients and influencing global currents. Without the moon's steady hand, our coastlines would be less diverse, less dynamic, and less productive. Even the air we breathe is connected to the tides. Tidal marshes and mangrove forests, those unique ecosystems that straddle the line between land and sea, play a critical role in absorbing carbon dioxide from the atmosphere. By harnessing the power of photosynthesis, they transform carbon dioxide into organic matter, helping to regulate Earth's climate. It's easy to think of the moon as a distant object, a mere spectator in the grand theater of life on Earth. But the reality is far more intricate. The moon is an active participant, a silent partner in the Earth's story. Its gravity shapes our oceans, influences our weather, and has, perhaps, played a critical role in the origin and evolution of life itself. So, the next time you stand on a beach, feel the sand between your toes and watch the tide come in. Remember the moon. Remember its pull, its rhythm, its gentle but persistent influence on our world. It is a reminder that even the seemingly distant forces can have a profound impact, and that life on Earth is intricately connected to the cosmos above since the dawn of life on Earth. The moon has been a silent timekeeper, its rhythmic influence shaping the very fabric of biological existence. The moon's predictable cycle of phases offered early organisms a reliable framework for navigating their world. But how did this celestial rhythm become so deeply ingrained in the biological processes of our planet? Let's delve into the fascinating story of how lunar cycles shaped early biological rhythms. Imagine a primordial Earth, bathed in the intense radiation of a young sun. The oceans, still teeming with nascent life, experienced extreme tidal fluctuations due to the moon's proximity. These weren't the gentle, lapping tides we see today. They were colossal surges, flooding vast stretches of coastline and then receding, leaving behind pools of concentrated minerals and organic compounds. In these dynamic tidal pools, life began to experiment with rhythm, the lunar cycle. Approximately 29.5 days became a fundamental unit of time. For early organisms, especially those living in the intertidal zones, synchronizing their activities with a lunar rhythm was a matter of survival. Organisms that could anticipate the ebb and flow of the tides, the changing levels of light and darkness associated with the lunar phases, had a distinct advantage. They could prepare for the incoming tide, find shelter during low tide, and maximize their opportunities for feeding and reproduction. One of the most significant ways lunar cycles shaped early biological rhythms was through the evolution of internal biological clocks. These weren't precise timekeeping mechanisms like modern clocks. They were more like internal metronomes, helping organisms track the passage of time and anticipate periodic environmental changes. Over millions of years, natural selection favored organisms with internal clocks that closely matched the lunar cycle. These clocks governed a wide range of biological processes, from metabolism and growth to reproduction and behavior. Some organisms, for example, timed their feeding cycles to coincide with high tide when food was more abundant. Others timed their reproductive cycles to coincide with specific lunar phases, such as the full moon when the tides were strongest. Consider the case of marine invertebrates like crustaceans and mollusks. Many of these creatures exhibit remarkable lunar synchrony in their reproductive behavior. Some species release their eggs and sperm into the water only during specific lunar phases, maximizing the chances of fertilization. Others migrate to breeding grounds at precise times of the lunar cycle, ensuring that their offspring hatch under optimal conditions. The Pallola worm presents a truly remarkable example of lunar synchronized reproduction. These marine worms inhabit the tropical Pacific Ocean. During specific phases of the moon in October and November, they emerge from the coral reefs and release their reproductive segments into the water in a synchronized mass spawning event. The timing is so precise that it can be predicted years in advance, a testament to the power of lunar cycles to orchestrate biological events. Even in organisms that don't directly interact with the tides, lunar cycles can exert a subtle but significant influence. Many nocturnal animals, for example, adjust their activity levels based on the amount of moonlight available. Some predators are more active during full moons when their prey are easier to see, while their prey become more cautious and less active. During those same periods, early humans, too, were profoundly affected by lunar cycles. Hunter-gatherer societies likely timed their hunting expeditions and migrations to coincide with the lunar phases. The full moon provided extra light for nighttime activities, while the new moon offered a period of rest and reflection. The lunar cycle also served as a natural calendar, helping early humans track the passage of time and plan for future events. But what about the underlying mechanisms? How exactly do organisms sense and respond to lunar cycles? The answer is complex and still not fully understood. It likely involves a combination of factors, including light, gravity, and electromagnetic fields. Some organisms may have specialized receptors that detect changes in moonlight intensity or polarization. Others may respond to subtle changes in gravity caused by the moon's pull. And yet others may be sensitive to electromagnetic fields that fluctuate with the lunar cycle. It's also important to recognize that the influence of lunar cycles on biological rhythms isn't static. It has evolved over time as organisms have adapted to changing environmental conditions. As Earth's rotation slowed and the moon gradually receded, the tidal forces changed and the lunar cycle became less pronounced. Organisms had to adapt their internal clocks and behavioral patterns accordingly. In some cases, they may have shifted their reliance from lunar cues to other environmental signals, such as the daily cycle of light and darkness, or the seasonal cycle of temperature changes. Today, even with our artificial lighting and modern technology, lunar cycles continue to exert a subtle influence on our lives. Some studies suggest that human sleep patterns, mood, and even fertility may be affected by the lunar phases. The evidence is still mixed, and more research is needed. But the idea that we are still, in some way, connected to the ancient rhythms of the moon is intriguing and deeply poetic. The moon, our silent timekeeper, has left an indelible mark on the biological processes of Earth. From the evolution of internal clocks to the synchronization of reproductive cycles, lunar cycles have shaped the rhythms of life in countless ways. And even as we venture further into the cosmos, we carry those ancient rhythms with us, a testament to the enduring power of the moon to influence our world. As the moon waxes and wanes, casting its silvery light upon our planet, it reminds us that time is a river flowing through us, carrying us forward in an endless dance with the cosmos. Let's turn our gaze back in time, far beyond the glow of electric lights and the hum of modern cities. Let's picture early humans huddled around crackling fires, their world bounded by the setting sun and the rising moon. Moonlight, for them, wasn't a romantic backdrop. It was a lifeline, a guide, and a shaper of daily life. It dictated when to hunt, when to gather, when to travel, and when to seek the safety of shelter. Imagine those first civilizations without any artificial light. The stars would have blazed with a brilliance we can scarcely comprehend, a celestial canvas stretching across an ink-black sky. But the moon, in its cycles, would have been a much more reliable and practical source of illumination. It offered light that was gentle but persistent, strong enough to reveal paths, shapes, and dangers lurking in the shadows. Under the full moon, the world transformed. The darkness receded, and the boundaries of activity expanded. Hunters could track prey more easily, following the glint of fur or the subtle movements against the moonlit landscape. Gatherers could venture farther from their settlements, searching for edible plants and resources with a greater degree of safety. Even travel, often perilous in the dark, became less daunting. Paths were clearer, obstacles more visible, and the risk of stumbling into unseen hazards diminished. But perhaps the most profound impact of moonlight on early humans was its influence on social behavior. As the sun dipped below the horizon, families and communities would gather around their fires, drawn together by warmth, companionship, and the shared awareness of the surrounding darkness. But on moonlit nights, those gatherings could extend longer, become more animated, more vibrant. The extra light encouraged conversation, storytelling, and communal activities. Myths and legends were woven under the watchful gaze of the moon, passed down through generations in the flickering firelight. Decisions were made, alliances forged, and social bonds strengthened in the shared glow of that silvery sphere. The moon also influenced the rhythms of sleep. Without the rigid schedules imposed by artificial lighting, early humans likely followed a more natural sleep pattern dictated by the ebb and flow of daylight and moonlight. On moonless nights, they might have retreated to their shelters earlier, seeking refuge from the darkness and predators. On moonlit nights, they might have stayed awake longer, enjoying the extended period of activity and social interaction. Perhaps they slept less deeply, their senses attuned to the sounds and sights of the nocturnal world. But the relationship between moonlight and early human behavior wasn't just about practicality. It was also about the psychological and emotional impact of the lunar cycle. The moon's phases, its waxing and waning, its cycles of absence and return mirrored the rhythms of life itself. The new moon, a period of darkness and introspection, might have been associated with rest, reflection, and preparation. The full moon, a time of heightened illumination and activity, might have been associated with celebration, fertility, and abundance. These associations, passed down through generations, shaped cultural beliefs, rituals, and traditions. Lunar calendars became essential tools for tracking time, planting crops, and organizing social events. Myths and legends grew up around the moon, imbuing it with divine powers and symbolic meanings. And even today, echoes of those ancient beliefs can be found in our language, our art, and our subconscious. Consider the word lunatic, derived from the Latin word luna, meaning moon. It reflects the ancient belief that the moon could influence human behavior, driving individuals to madness or irrationality. Or consider the many love songs and poems that invoke the moon as a symbol of romance, longing, and the ethereal beauty of the night. These are not simply modern inventions. They are echoes of a relationship that stretches back to the dawn of humanity. a relationship shaped by the practical realities of living in a world lit only by the moon. Even architecture was quietly influenced. There is no direct line, but think of cave paintings found around the world that document not only large animals, but also specific points on the moon and constellations. Early attempts at building design may well have begun with consideration for the amount of moonlight allowed into a communal space. So next time you glance up at the moon on a clear night, imagine yourself as one of those early humans, gazing at that same glowing sphere with a mixture of awe, respect, and dependence. Remember that its light has guided us for millennia, shaping our behavior, structuring our societies, and weaving its way into the very fabric of our being. The moon wasn't just a celestial object. It was a partner, a companion, and a constant presence in a world that was both beautiful and perilous. And in a very real sense, it helped make us who we are. Let's chart time's celestial compass with a topic close to my heart: lunar calendars. Imagine ancient civilizations looking up at the same moon we see tonight and divining from its phases the very rhythm of their lives. Long before there were smartphones or digital clocks, the moon was the sky's reliable timepiece and the most accurate calendar humans possessed. Think about it. What could be more dependable, more universally accessible than the moon's predictable cycle of phases? Before writing, before formal mathematics, before even the wheel, the moon was there. A natural timepiece etched across the night sky. A silent guide to planting seasons, animal migration, and the ebb and flow of daily life. A lunar calendar, at its essence, is a system of timekeeping based on the cycles of the moon's phases. Unlike solar calendars, which track Earth's orbit around the sun, lunar calendars stick exclusively to the moon's roughly 29.5-day journey from new moon to new moon, sometimes referred to as a synodic month. In these ancient systems, each month begins with the first sighting of the crescent moon, following a new moon, and concludes with the next. It's an elegant method, simple to observe, and surprisingly accurate if your focus is the short term. But here's where things get complicated. 12 lunar months only add up to about 354 days, which is roughly 11 days shorter than the solar year. That means a purely lunar calendar, without adjustments, will gradually drift out of sync with the seasons. For societies heavily reliant on agriculture, this presents a challenge. Planting, harvesting, and celebrating seasonal events in alignment with the cosmos requires keeping track of both the moon and the sun. Enter the lunisolar calendar, a clever hybrid system that reconciles lunar months with a solar year. These systems add an extra intercalary or leap month every few years to keep the calendar aligned with the seasons. Different cultures have employed various methods for determining when to insert this extra month, often relying on agricultural indicators or astronomical observations. The ancient Babylonians, for instance, used a lunisolar calendar that inserted an extra month 7 times in a 19-year cycle, a pattern known as the Metonic cycle. The Chinese, Hebrew, and some indigenous cultures continue to use these lunisolar calendars to this day. But let's take a step back to the cultures that gave our modern measurements their shape. To fully appreciate the lunar calendar's significance, we need to consider its historical context. In Mesopotamia, the cradle of civilization, the Sumerians and Babylonians meticulously tracked the movements of the moon. Their lunar calendars, dating back thousands of years, were used not only for practical purposes, but also for religious and ceremonial events. The Babylonians believed that celestial events were directly linked to earthly affairs. So accurate timekeeping was essential for appeasing the gods and ensuring the well-being of the kingdom. Their sophisticated system of mathematics allowed them to predict lunar eclipses and calculate the length of the lunar month with remarkable precision. In ancient Egypt, while the official calendar was primarily solar, the moon still held great significance. The Egyptians associated the moon with various deities and tracked its phases for religious festivals. The lunar cycle also played a role in agricultural practices, as farmers observed the moon's influence on the Nile River's annual flood. It's this relationship between the celestial and terrestrial that defined their society and its calendar, moving eastward. The ancient Chinese developed a complex lunisolar calendar that continues to be used today. This calendar is not just a tool for measuring time, but also a reflection of Chinese cosmology and philosophy. Each year is associated with one of 12 animals from the zodiac, and each month is aligned with specific agricultural tasks. The Chinese lunar calendar governs many traditional festivals, such as the Spring Festival, also known as Chinese New Year, which falls on the first day of the Lunar New Year. Across the ocean in Mesoamerica, the Maya civilization developed an intricate system of calendars, including a lunar calendar that was used for ritual purposes. The Maya tracked the phases of the moon with extraordinary accuracy, and their calculations were used to predict eclipses and determine auspicious dates for ceremonies. The lunar calendar was intertwined with the Maya's complex system of mathematics and astronomy, demonstrating their deep understanding of the cosmos. Now, let's consider the legacy of these ancient systems. The influence of lunar calendars can still be seen in many modern cultural and religious traditions. The Islamic calendar, for example, is a purely lunar calendar, meaning that its months are based solely on the phases of the moon. As a result, Islamic holidays shift across the seasons each year. The Jewish calendar, on the other hand, is a lunisolar calendar that incorporates leap months to keep it aligned with the solar year. This calendar governs the timing of Jewish holidays such as Passover and Rosh Hashanah. Easter, the most important festival in the Christian calendar, is determined using a lunisolar calendar as well. Easter Sunday falls on the first Sunday after the first full moon following the vernal equinox, connecting this Christian holy day to the celestial rhythms of the moon. But beyond these religious and cultural traditions, what does the lunar calendar tell us about ourselves? For one, it is a testament to humanity's ability to observe, interpret, and make sense of the natural world. By tracking the moon's phases, ancient civilizations developed a deep understanding of the cosmos and its influence on earthly affairs. The lunar calendar is also a reminder of our connection to the past, linking us to cultures and traditions that stretch back thousands of years. By studying these ancient systems, we can gain insights into how humans have perceived time, organized their lives, and made sense of their place in the universe. Moreover, the lunar calendar emphasizes the importance of cycles in human life. The moon's waxing and waning phases serve as a constant reminder that everything is in a state of flux, constantly changing and evolving. This cyclical view of time is a fundamental aspect of many spiritual and philosophical traditions, and it contrasts with the linear view of time that dominates much of modern Western thought. So tonight, the next time you gaze up at the moon, consider all of its phases that came before and the cultures that used this steady cycle to guide them. Take a moment to appreciate the ingenuity and creativity of those who used the moon to chart time, predict the seasons, and connect with the cosmos. The lunar calendar is more than just a system of timekeeping. It is a window into the human mind, a reflection of our deep-seated desire to find order, meaning, and beauty in the world around us. For most of human history, getting around on the water wasn't as easy as plugging an address into a GPS. There were no satellites overhead, no detailed charts, and certainly no brightly lit shipping lanes. Yet, despite these challenges, early seafarers managed to navigate across vast stretches of ocean, connecting distant lands and charting the unknown. And one of their most reliable guides, shimmering in the night sky, was the moon. Now, it might seem counterintuitive. The moon changes shape, its position shifts, and sometimes it disappears altogether. How could such a variable object be a dependable tool for navigation? Well, for those who understood its rhythms and patterns, the moon provided a wealth of information, offering light, a celestial clock, and a key to understanding the tides. Let's start with the most obvious advantage: moonlight. Before artificial lighting, the night was a truly dark place. Overcast skies turned travel treacherous, limiting movement to short distances near familiar landmarks. The moon changed that equation. A full moon could cast enough light to illuminate coastlines, river mouths, and even open stretches of water. Sailors could see the horizon, identify landmarks, and steer clear of dangerous obstacles. Imagine early Polynesian voyagers setting out on a journey across the Pacific. They didn't have compasses or sextants, but they did have an intimate knowledge of the stars and the moon. They used the stars to establish a general direction, memorizing the rising and setting points of key constellations. But on cloudy nights, when the stars were obscured, the moon became their primary guide. The moon's position, its phase, and even the angle at which it hung in the sky offered crucial clues. Experienced navigators could predict the path the moon would take across the night and use that knowledge to stay on course. They also knew the moon rose in different locations depending on the season. Tracking those changes throughout the year allowed them to create a mental map of the heavens, a map that guided them to distant islands thousands of kilometers away. Beyond illumination, the moon also helped seafarers keep track of time. Long before accurate clocks, calculating longitude or east-west position was nearly impossible. But sailors could use the moon to estimate how far they had traveled. A full lunar cycle, from new moon to new moon, takes about 29.5 days. Experienced navigators divided that cycle into smaller segments, learning to associate each lunar phase with a certain number of days at sea. If they knew their speed and direction, they could estimate their longitude based on the moon's progression, a kind of celestial stopwatch helping them gauge their progress across the ocean. However, perhaps the most crucial navigational tool offered by the moon was the tides. Tides are the rhythmic rise and fall of sea levels caused primarily by the moon's gravitational pull. The relationship between the moon and the tides is complex, but the basic principle is simple. As the moon orbits the Earth, its gravity pulls on the oceans, creating a bulge of water on the side of Earth facing the moon. As the Earth rotates, this bulge moves around the planet, causing high tides and low tides in predictable cycles. Sailors throughout history have used their knowledge of the tides to their advantage. They knew that high tides could help them cross sandbars, navigate narrow channels, and access coastal harbors that were otherwise inaccessible. Low tides, on the other hand, could reveal hidden dangers, expose reefs, and shoals, and strand unwary. Vessels, understanding the timing and strength of the tides, was crucial for safe navigation. Experienced seafarers could predict high and low tide times based on the moon's position and phase. They knew that spring tides, the highest and lowest tides, occurred around the time of new and full moons, when the sun and moon align and their gravitational pulls combined. Neap tides, the weaker tides, occur during the quarter moons, when the sun and moon were at right angles to each other. This knowledge allowed them to plan their voyages accordingly, choosing the most favorable times to enter or leave port, navigate treacherous waterways, and avoid running aground. In many coastal communities, the local knowledge of tides was passed down through generations, becoming an essential part of maritime culture. Sailors learned to read the subtle signs of the changing tides, observing the behavior of currents, the height of the water, and the position of the moon. They developed an intimate understanding of their local waters, using the moon as their guide to navigate safely and efficiently. The moon's role in navigation also extended to celestial navigation. By measuring the angle between the moon and the horizon, sailors could determine their latitude or north-south position. This technique, known as lunar distance, required precise observations and complex calculations, but it was a valuable tool for long-distance voyages. Lunar distance was particularly important in the age of exploration, when European powers began sending ships across the Atlantic and Pacific Oceans. Navigators used specialized instruments, like sextants and octants, to measure the angle between the moon and other celestial bodies, including stars and planets. These measurements, combined with tables and calculations, allowed them to determine their latitude with reasonable accuracy. While lunar distance was a valuable technique, it was also challenging. It required clear skies, steady instruments, and skilled observers. Small errors in measurement could lead to significant errors in latitude. As a result, many sailors preferred to rely on simpler, more intuitive methods of navigation, such as dead reckoning, estimating their position based on speed, direction, and time. But even dead reckoning relied on a basic understanding of the moon's influence on tides and currents. Today, with the advent of GPS technology and electronic charts, the moon's role in navigation has diminished. But even in our age of digital precision, the moon continues to inspire wonder and awe. We still look up at its pale glow in the night sky, a reminder of our connection to the cosmos and of the ingenuity of those early seafarers who navigated the world by the light of the moon. The moon serves as a reminder of a time when humans were more intimately connected to the natural world, reading the signs of the sky and the sea to find their way. And perhaps In our increasingly disconnected world, we can learn from those early navigators to appreciate the beauty and power of the moon and to find our own way, guided by its gentle light, across civilizations. From the dawn of agriculture to the digital age, the moon hasn't just been a passive observer. It's been a canvas onto which cultures have projected their deepest beliefs, fears, and aspirations. Its cyclical nature, its soft glow, and its constant presence have inspired a vast tapestry of mythology and symbolism that continues to resonate. Even today, let's begin our exploration with ancient Mesopotamia, the cradle of civilization. Here, the moon was personified by the god Sin, also known as Nana, a wise and revered deity. Sin wasn't just a celestial body. He was the father of the sun god Shamash and the goddess Ishtar, a central figure in the Mesopotamian pantheon. He was often depicted as an old man with a flowing beard, riding a winged bull, or sailing in a crescent-shaped boat across the night sky. Temples were dedicated to Sin in cities like Ur and Haran, and his priests meticulously tracked the lunar cycles to determine the calendar and schedule religious festivals. For the Mesopotamians, Sin was the keeper of time, the giver of wisdom, and the embodiment of the night itself. Moving eastward, we encounter Chandra, the lunar deity in Hinduism. Chandra is depicted as a handsome young man, often riding a chariot, pulled by a team of white horses. He's associated with dew, fertility, and the soothing coolness of the night. The phases of the moon are seen as a reflection of the ebb and flow of emotions, a reminder that life is a cycle of joy and sorrow, growth and decay. Chandra also plays a significant role in astrology, where he governs the mind, emotions, and intuition. A strong lunar presence in a person's birth chart is said to indicate a sensitive and empathetic nature in ancient Egypt. The moon held a more complex and multifaceted significance. The god Thoth, often depicted with the head of an ibis or a baboon, was associated with the moon, as well as with wisdom, writing, and magic. Thoth was said to have measured time, invented the calendar, and recorded the deeds of the gods. He was a powerful figure in the Egyptian pantheon, and his association with the moon underscores its importance as a celestial timekeeper. The moon also represented the Eye of Horus, a symbol of protection, healing, and royal power. The waxing and waning phases of the moon mirrored the cyclical nature of life, death, and resurrection, a central theme in Egyptian mythology. Across the Pacific Ocean, in the Polynesian cultures, the moon was a vital guide for navigation and a source of deep spiritual connection. Polynesian navigators, masters of open ocean voyaging, used the moon's phases, position, and relationship to the stars to chart their course across vast distances. The moon wasn't just a celestial object. It was a living presence, a guide, and a protector. Legends tell of ancestral voyages guided by the moon's light, of gods and goddesses who dwelled within its craters, and of the profound interconnectedness between the sky, the sea, and the human spirit. Turning to the Americas, we find diverse lunar mythologies among indigenous cultures. The Maya, renowned for their sophisticated astronomical knowledge, revered the moon goddess Ixchel, often depicted as an old woman weaving at a loom. Ixchel was associated with childbirth, healing, and the cyclical nature of life. The Mayans meticulously tracked the lunar cycles and incorporated them into their complex calendar system, which played a crucial role in their agriculture, rituals, and prophecy. Further north, among many Native American tribes, the moon was seen as a female deity, a grandmother figure, or a sister to the sun. The moon was often associated with water, fertility, and the cyclical rhythms of nature. Stories tell of the moon's power to influence the tides, control the seasons, and guide the spirits of the dead. In some traditions, the moon was also seen as a trickster figure, a reminder that even in the heavens, chaos and mischief could prevail. In Norse mythology, the moon was personified as Mani, a male god who drove the moon across the sky in a chariot, pulled by two children. He was relentlessly pursued by a wolf named Skull, a terrifying beast who sought to devour him. This perpetual chase was said to be the cause of lunar eclipses, a time when the moon was momentarily captured by the wolf's jaws. The story of Mani and Skull reflects the Norse worldview of a cosmos constantly threatened by chaos and destruction. And, of course, let's not forget the darker side of lunar mythology, the association of the moon with madness, with the term lunatic derived from the Latin word luna, speaks to a long-held belief in the moon's power to influence human emotions and behavior. The werewolf legend, with its tales of humans transforming into wolf-like creatures under the full moon, captures the primal fear of losing control, of succumbing to the wild and untamed forces within. These are just a few glimpses into the rich and varied tapestry of lunar mythology across civilizations. Each culture has woven its own stories, its own beliefs, and its own symbolism around the moon, reflecting its unique worldview and its relationship with the cosmos. The moon, in its silent and ever-changing presence, has served as a mirror, reflecting humanity's deepest hopes, fears, and aspirations. It remains a testament to our enduring fascination with the night sky and our unyielding need to find meaning in the celestial dance above. So, as you look up at the moon tonight, remember the countless stories it has inspired, the gods and goddesses it has represented, and the enduring power it holds in the human imagination. It's more than just a rock in the sky. It's a symbol of our shared human experience, a reminder of our connection to the cosmos, and a canvas for our dreams. Let's turn our gaze now to the drama in the night sky. Those moments when the moon, our steadfast companion, undergoes a transformation both eerie and mesmerizing, the lunar eclipse. For eons, these events, where the moon seemingly vanishes or takes on a crimson hue, were shrouded in mystery, interpreted through lenses of mythology, fear, and awe. But beneath the tapestry of legends, a beautiful and understandable science unfolds. Across civilizations, lunar eclipses were seldom seen as mere celestial events. They were cosmic omens, celestial dramas carrying messages from the divine. Imagine being an ancient shepherd watching the moon, your reliable guide through the night, slowly being consumed by darkness. Panic might ensue. Whispers of angry gods or impending doom might fill the air. The Incas, for instance, believed that a jaguar was attacking and devouring the moon. In response, they would clang pots, howl at the heavens, and even unleash their dogs, hoping to create enough noise and chaos to scare off the beast and restore their lunar deity. Failure to do so, they feared, would bring misfortune, famine, or even the complete collapse of their world. In other cultures, lunar eclipses were seen as signs of a celestial battle. Two mighty forces locked in a cosmic struggle. The fate of the world hanging in the balance. Drums would beat, arrows would fly, and prayers would rise, all in an attempt to influence the outcome, to ensure that light triumphed over darkness. That order prevailed over chaos. Even in cultures that didn't necessarily fear the eclipse, they recognized it as a time of heightened power and significance. Some Native American tribes viewed it as a time of renewal and rebirth. Old grudges were forgiven, alliances were forged, and ceremonies were performed to cleanse the community and prepare for the future. But what is truly happening during a lunar eclipse? Strip away the mythology, and we reveal a cosmic ballet, an elegant dance of shadow and light. A lunar eclipse, in its simplest terms, occurs when the Earth passes directly between the sun and the moon, casting its shadow upon the lunar surface. Picture it, the sun, a fiery orb of constant energy, the Earth, our home, spinning and orbiting, and the moon, our celestial partner, tracing its own path through space. When these three align perfectly, a shadow play begins. Earth casts to shadows, the umbra, a dark, central shadow, where the sun is completely blocked, and the penumbra, a lighter, more diffuse shadow, where the sun is only partially obscured. Now, consider the moon's journey. As it orbits Earth, it sometimes passes through these shadows. If it only enters the penumbra, we witness a penumbral lunar eclipse, a subtle dimming of the lunar surface, often so faint that it goes unnoticed by casual observers. But when the moon ventures deeper into the umbra, the drama intensifies. A partial lunar eclipse unfolds, where a dark, curved shadow creeps across the lunar disk, slowly obscuring its familiar features. Craters fade, Maria darken, and the moon begins to lose its silvery glow. And then, if the alignment is precise, the entire moon plunges into the Earth's umbra. A total lunar eclipse occurs, an event that can last for over an hour, transforming the moon into a spectacle of color. But why doesn't the moon simply disappear? Why does it often turn a shade of red? The answer lies in our own atmosphere, that thin veil of gases that protects and sustains life on Earth. Even though the Earth blocks direct sunlight, some light still manages to reach the moon, bending and scattering as it passes through our atmosphere. This is where the magic happens. Shorter wavelengths of light, like blue and violet, are scattered away, while longer wavelengths, like red and orange, are able to bend around the Earth and reach the lunar surface. It's the same principle that gives us fiery sunsets and vibrant sunrises. During a total lunar eclipse, the Earth's atmosphere acts like a giant lens, filtering and refracting sunlight, casting a reddish glow upon the moon. The color can vary, depending on atmospheric conditions, from a deep crimson to a subtle copper, even a brownish hue. Volcanic eruptions, for example, can inject vast amounts of dust and aerosols into the atmosphere, affecting the color and intensity of the eclipse. A particularly dusty atmosphere can result in a darker, more muted eclipse, while a clearer atmosphere can produce a brighter, though vibrant, display. The term blood moon has gained popularity in recent years, often used to describe a total lunar eclipse. While the name evokes images of dread and foreboding, it's simply a reflection of the red hue the moon often takes on during totality. There is something rather marvelous in understanding the science behind a lunar eclipse. It transforms what once seemed like a mysterious and terrifying event into a beautiful demonstration of celestial mechanics. It connects us to the universe in a tangible way, reminding us that we are part of a larger cosmic dance. The next time you witness a lunar eclipse, Take a moment to appreciate its beauty, its science, and its history. Think of the ancient civilizations who watched the same event with wonder and fear, and consider how far we've come in understanding the cosmos. For in that fleeting darkness, in that crimson glow, lies a connection to our past, a glimpse into our present, and a sense of awe for the infinite possibilities of the universe. Let's talk about farming. Not just the kind with combine harvesters the size of small houses, but the kind our ancestors did. The kind that felt deeply connected to the earth and the sky, especially to the moon, for millennia. Farmers have looked to the moon as a guide for planting, tending, and harvesting their crops. This practice, known as lunar agriculture, or farming by the moon's phases, is rooted in the belief that the moon's gravitational pull and its varying light levels influence plant growth. It might sound a little like something out of a fairy tale, but this tradition holds a wealth of wisdom. Now, how does it all work? Well, the core concept is pretty simple. The lunar cycle, which takes about 29.5 days from new moon to new moon, is divided into 4 main phases. We've got the new moon, that invisible time when the moon sits between the earth and the sun, and its light isn't cast onto our view here on earth. From this point, we move into the waxing crescent. The waxing moon is the period when the moon is growing, slowly inching towards becoming a full circle, and that's followed by the first quarter. The full moon, when the earth sits in between the moon and the sun, then graces the night sky. After this, the moon starts to wane once again, shrinking back to becoming the opposite of a crescendo, a diminuendo, if you will. It goes through the third quarter to the waning gibbous and then into the waning crescent, finally arriving back into a new moon again. So the farmers noticed that the first 2 phases of the lunar cycle, from new moon to full moon, this is known as the waxing moon and is considered an ideal time for planting crops that thrive above ground, things like leafy greens, beans, grains, and fruits. The idea is that as the moon grows brighter and its gravitational pull increases, it encourages upward growth, stimulating foliage and fruit production. Then, during the last 2 phases, from full moon to new moon, which we call the waning moon, that's the time to focus on root crops, things like carrots, potatoes, beets, and onions. The belief is that as the moon's light and gravitational pull decrease, energy shifts downward, encouraging the development of strong, healthy roots. This is also a good time for tasks like pruning, weeding, and fertilizing. As for what science says about all this, well, the jury's still out. There haven't been a ton of large-scale scientific studies that definitively prove the benefits of lunar agriculture. But many farmers swear by it, and there are some intriguing ideas about why it might work, even if only a little. One possibility is that the moon's gravity really does have some subtle influence on soil moisture. Just as it pulls on the oceans to create tides, it might also pull on water within the soil, encouraging germination and root development during certain phases. Another factor could be the moon's light itself. Even though moonlight is far fainter than sunlight, it's still light, and it could potentially affect plant growth or the activity of soil microorganisms. Beyond the science, lunar agriculture is also about tradition and connection to the land. For centuries, farmers have relied on the moon as a natural calendar, observing its phases to determine the best times for planting and harvesting. It's a way of aligning your work with the rhythms of nature, of tapping into a deeper, more intuitive understanding of the world around you. And many cultures have built elaborate agricultural systems around the moon's cycles. In ancient Mesopotamia, the Babylonians carefully tracked the moon's movements, using lunar calendars to guide their planting and harvesting schedules. Egyptian farmers relied on the moon to predict the flooding of the Nile, a crucial event that brought fertile silt to their fields. And in many parts of the world, indigenous communities continue to follow lunar traditions, passing down knowledge from generation to generation. Whether it's rooted in science or tradition, lunar agriculture offers a compelling alternative to the industrialized, highly technological farming of today. It's a reminder that farming isn't just about maximizing yields and profits. It's about creating a relationship with the land, about respecting the cycles of nature, and about working in harmony with the cosmos. So, next time you're planning your garden, maybe take a look at the moon. It might not guarantee a bumper crop, but it'll certainly add a bit of magic and mystery to your planting. And even if you're not a farmer, the moon can remind us all to slow down and connect with the natural rhythms that surround us. A world where the seasons themselves give permission to go to sleep. And now, let's drift closer to the moon itself. A journey not of miles, but of understanding. We've explored its global impact, its steadying hand on our planet, its influence on tides and seasons. But what about its more intimate connection? The whispers it sends to our sleeping minds, the echoes it leaves in our dreams. The link between the moon and sleep is ancient, woven into the fabric of folklore, medicine, and the very way we've perceived the night for millennia. Long before electric lights banished true darkness, our ancestors lived in a world profoundly shaped by lunar cycles. A full moon meant brighter nights, extended activity, a world where shadows danced with a silvered clarity. A new moon, on the other hand, brought an absolute darkness, a call to retreat, to rest, to gather close and wait for the return of the light. This ancient dance between light and dark, between lunar rhythm and human behavior, likely shaped our sleep patterns in subtle ways. Modern science is only beginning to unpack these connections. The question of the moon's influence on sleep has been the subject of surprisingly robust and yet still inconclusive scientific inquiry. Let's have a look. For starters, there's the question of duration. Does the moon in any way influence how long or how deeply we sleep? Some researchers believe our bodies still carry remnants of these ancient lunar rhythms. These scientists have determined that the full moon can lead to shorter sleep duration, reduced sleep quality, and increased sleep latency, meaning it takes us longer to fall asleep. Others suggest that bright moonlight suppresses melatonin production, the hormone that regulates sleep, keeping us more alert even with our eyes closed. However, studies on melatonin and lunar cycles are far from conclusive, and it's clear that individual responses can vary greatly. Some people are deeply affected by the moon, reporting significant sleep disturbances during full moons, while others seem entirely immune. Another approach focuses on brainwave activity. One interesting idea is that brainwave patterns and sleep cycles somehow reflect the moon's phases. Maybe our brains exhibit more activity and less deep sleep near the full moon, with our neural activity shifting once again during the new moon. Yet, as often happens in science, what sounds intuitive can be incredibly difficult to demonstrate. And as is also often the case, the modern world is quite confusing to analyze. Modern living is messy and rarely pure. Many studies struggle to filter out the noise of modern life from the subtle lunar signal. Screens, streetlights, irregular schedules, indoor climate control, all can overwhelm our data, obscuring ancient connections. While some studies find suggestive correlations, others find nothing at all. This leaves scientists with a collection of intriguing observations and frustrating inconsistencies. Is it the moon? Or just the normal chaos of our complicated human lives? It's tempting to dismiss the entire idea as mere folklore, a quaint holdover from a less scientific age. But the fascination persists, and there's a feeling that the human connection is real, even if the science is still catching up. So perhaps, instead of focusing solely on sleep, quantity, and quality, let's consider the more subjective dimensions of lunar influence. For this, we must wade into the subjective. What about the moon's power to shape dreams, to stir emotions, to whisper through the subconscious? This is where things become less measurable, but perhaps even more meaningful. The moon has always been a potent symbol of the subconscious, representing intuition, emotion, and the hidden currents that flow beneath the surface. Our ancestors believed that the moon could unlock aspects of the human mind, a doorway into the imagination, and of all things human, sleep and dreams may well be the most mysterious of all. As a result, it's no surprise that the moon is seen as being at its most powerful in the realm of sleep. If you've ever lain awake on a moonlit night, you may have noticed how thoughts take on a different quality in that silver glow. Boundaries blur between reality and fantasy, memories resurface, and the imagination takes flight. Moonlight has a way of illuminating not just the landscape, but also the inner terrain of our minds. The moon becomes a mirror, reflecting our emotions, our longings, our fears, and our hopes. Some believe that certain phases of the moon are more conducive to vivid or prophetic dreams. Full moons, with their heightened energy, are said to bring intense dreams, rich with symbolism and emotion. New moons, shrouded in darkness, may invite more introspective, shadowy, or even unsettling dreams. It's as if the lunar cycle stirs different corners of our subconscious, unlocking hidden narratives, and even if these beliefs lack scientific validation, they tap into something essential about the human experience. We crave meaning, we seek patterns, we long to connect with the rhythms of the natural world. Whether it's a conscious ritual or a subconscious hum, the moon invites us to look inward, to listen to the whispers of our own souls. Whether you're a scientist, a dreamer, or somewhere in between, the moon continues to inspire awe and curiosity. As science gives us new tools to understand its physical nature, perhaps we can also appreciate its enduring power as a symbol. The moon isn't just a destination, a world to explore. It's a companion, a reminder, a mirror reflecting who we were, who we are, and who we might yet become under the watchful glow of the night sky. The moon, our celestial neighbor, has been a muse for artists, musicians, and writers throughout history. It's a silent, silvery presence that has inspired countless works of art, each reflecting a unique perspective on its ethereal beauty and mystique. Think of the visual arts. Painters have long been captivated by the moon's soft glow and the way it transforms landscapes. From the serene moonlit scenes of Caspar, David, Friedrich, with figures contemplating the vastness of nature under a watchful moon, to the swirling, emotional intensity of Vincent van Gogh's Starry Night, where the crescent moon seems to pulse with an energy all its own. Artists have used the moon to evoke a range of emotions, from tranquility to a profound sense of longing. And let's not forget the pre-Raphaelites, who painted ethereal maidens gazing wistfully at the moon, capturing a romanticized vision of feminine beauty and connection to the natural world. The moon becomes a symbol of purity, mystery, and unattainable desire, a theme that resonates across many artistic traditions. Turning to music, the moon's influence is just as profound. Composers have used its phases and light to evoke moods and narratives. Beethoven's Moonlight Sonata, though not explicitly named by the composer himself, has long been associated with the moon's gentle glow. Its melancholic melody capturing a sense of nocturnal contemplation. It's the soundtrack to countless quiet evenings spent gazing out of windows, letting the moon's light wash over us. And then there's Claude Debussy's Clair de Lune, a shimmering, impressionistic piece that paints a musical picture of moonlight filtering through trees. Its delicate harmonies and flowing melodies create an atmosphere of ethereal beauty, a reminder of the moon's power to transform the mundane into something magical. Jazz standards, too, often feature the moon as a central theme. Blue Moon, How High the Moon, and Munglo are just a few examples of songs that use the moon as a metaphor for love, loss, and the bittersweet emotions of the human experience. The moon becomes a symbol of unattainable desire, a distant beacon that inspires longing and a touch of melancholy. But the moon's influence extends far beyond classical and jazz music. It permeates popular culture, from rock anthems to folk ballads, each offering a unique take on the moon's enduring appeal. Think of Pink Floyd's Dark Side of the Moon, an album that explores themes of madness, alienation, and the human condition, using the moon as a symbol of the unknown and the hidden aspects of our psyche. And let's not forget the literary world, where the moon has been a constant source of inspiration for poets, novelists, and playwrights. Shakespeare, in Romeo and Juliet, famously questions the moon's constancy, using it as a symbol of fleeting love. Its undeniable presence in the night sky. The romantic poets like Wordsworth, Shelley, and Keats were particularly drawn to the moon's mystique. They saw it as a reflection of human emotions, a symbol of the sublime, and a source of inspiration for their lyrical verses. The moon became a mirror for their own inner landscapes, a canvas for their hopes, fears, and longings. In modern literature, the moon continues to inspire writers from all genres. From science fiction epics, where the moon becomes a colony, a battlefield, or a refuge, to fantasy novels, where it's a source of magical power or a gateway to other worlds. The moon's presence is felt across the spectrum of storytelling. Even in children's literature, the moon plays a prominent role. Good Night Moon by Margaret Wise Brown is a beloved bedtime story that uses the moon as a symbol of comfort, security, and the gentle transition from wakefulness to sleep. It's a reminder that even in the darkest of nights, the moon is there, watching over us, offering a sense of peace and tranquility. But why does the moon hold such a powerful sway over our imaginations? Perhaps it's because it's a constant presence in our lives, a familiar face in the night sky that connects us to something larger than ourselves. Or perhaps it's because its phases mirror the cycles of life, death, and rebirth, reminding us of the ebb and flow of existence. Whatever the reason, the moon's ability to inspire creativity is undeniable. And genre, a constant source of inspiration for artists, musicians, and writers throughout history. And as long as the moon continues to shine in the night sky, it will continue to spark our imaginations and fuel our creative endeavors. Throughout recorded history, humans have turned their gaze to the night sky. What did they see? Constellations, planets, and the ever-present moon. It's more than a mere source of light. It's a companion on Earth's journey through time. The moon has been an object of both scientific study and artistic inspiration for centuries, and its mysteries continue to unfold even today. So, let's explore the science of the moon from its earliest observations to modern discoveries. We'll also highlight its significance in human history and its surprising implications for the uniqueness of life on Earth. The relationship between humanity and the moon goes way back. Our earliest ancestors observed its cyclical changes. They tracked its phases and began to understand its connection to tides and seasons. These initial observations laid the groundwork for lunar calendars, guiding our early understanding of time before clocks or written records. The moon served as our celestial timekeeper, influencing everything from planting to spiritual practices. The ancient Greeks made significant contributions to our understanding of the moon. Philosophers like Anaxagoras correctly hypothesized that the moon was a sphere that reflected sunlight rather than emitting its own light. Aristotle, in his geocentric model of the universe, placed the moon as the boundary between the terrestrial and celestial realms. And then came Aristarchus of Samos. He proposed a heliocentric model with Earth and other planets in orbit around the sun. A radical idea. He also attempted to estimate the size and distance of the moon, though these estimates weren't entirely accurate. Still, these early thinkers laid the groundwork for a more scientific approach to studying the cosmos. The Islamic Golden Age saw significant advancements in lunar observation. Islamic scholars meticulously charted the moon's phases and positions, using this information to refine astronomical models and improve navigation. They calculated the length of the lunar month with greater precision than before and built sophisticated astronomical instruments for more accurate observations. Their findings, eventually making their way into Europe, helped fuel the scientific revolution with the invention of the telescope in the 17th century. Our view of the moon transformed dramatically. Galilei was among the first to turn this new instrument towards the heavens, and his observations of the moon revolutionized astronomy. He was shocked to see that the moon was not a smooth, perfect sphere as previously believed, but instead a world full of mountains, craters, and valleys, features remarkably similar to those found on Earth. These observations challenged the Aristotelian notion of a perfect and unchanging celestial realm, and provided the first real evidence that the moon was a physical world with its own geological features. Johannes Kepler, using Tycho Brahe's meticulous observations, formulated his laws of planetary motion, demonstrating that planets orbit the sun in ellipses rather than perfect circles. He also recognized that the moon's orbit was not perfectly circular, but slightly elliptical. And what would Newton have done without the moon? He used its motion to test his theory of universal gravitation. Newton realized that the same force that caused an apple to fall from a tree also kept the moon in orbit around the Earth. By calculating the gravitational force required to keep the moon in its orbit, Newton was able to provide a mathematical explanation of Kepler's laws and to demonstrate that gravity was a universal force acting throughout the cosmos. Centuries later, in the 20th century, our understanding of the moon took a quantum leap with the dawn of the space age. The Soviet Union and the United States engaged in a fierce competition, sent robotic probes to the moon, providing close-up images of its surface. The Apollo program was the culmination of these efforts. Between 1969 and 1972, 12 astronauts walked on the moon, collecting samples, conducting experiments, and leaving behind a legacy of scientific discovery. The lunar samples brought back by the Apollo missions provided an immense amount of information. Analysis revealed that the moon is composed of similar materials to Earth's mantle, strengthening the giant impact hypothesis. According to this theory, the moon formed from debris ejected into space when a Mars-sized object collided with Earth. These samples also allowed scientists to determine the age of the moon with greater precision and provided clues about the early history of the solar system. One of the most significant discoveries of recent years is the presence of water ice on the moon, particularly in the permanently shadowed craters near the lunar poles. This discovery has significant implications for future lunar exploration and potential colonization. Water ice could be used as a source of drinking water, oxygen, and even rocket fuel, making it easier and more sustainable to establish a permanent presence on the moon. The modern era of lunar exploration continues with missions such as NASA's Artemis program, which aims to return humans to the moon, including the first woman and the first person of color. These missions will not only advance our scientific understanding of the moon, but also pave the way for future human exploration of Mars and beyond. Private companies are also playing an increasing role in lunar exploration, with plans to send landers, rovers, and even tourists to the moon in the coming years. Today, the moon continues to inspire and captivate us. Its influence stretches far beyond its presence in the night sky, shaping our culture, our science, and our understanding of the universe. From early observations that guided our ancestors to cutting-edge research that pushes the boundaries of human knowledge, the moon remains a constant source of wonder and discovery. We understand that the moon isn't just a destination. It's a portal. It can propel our quest for knowledge. It continues to evolve, inviting us to turn our gaze skyward and explore the secrets held within its ancient craters and hidden depths. And perhaps, in time, the story of the moon will provide a key to understanding how life on Earth became so rich in the first place. The story of Earth is also, in many ways, the story of unlikely circumstances adding up to something extraordinary. From the precise distance to our sun, to the presence of liquid water, and the chemistry of our atmosphere, life on Earth seems to have won a kind of cosmic lottery. And one of the most interesting tickets in that lottery may well have been the moon and its peculiar history as a planetary scale impact survivor. The rare Earth hypothesis proposes that while simple life, microbes, and the like may be relatively common throughout the universe, complex life, the kind that builds cities and contemplates the stars, may be exceptionally rare. Not because the universe is hostile, but because the requirements for advanced life are incredibly stringent. Like a series of cosmic filters that only a few planets can pass through, and the moon, formed from the debris of a long-ago collision, might just be one of those critical filters. So, what is it about our moon that might make Earth so uniquely habitable? Well, to understand that, we need to imagine what Earth would be like without it. Think about the stability of our planets. Axial tilt. Earth spins on its axis, and that axis is tilted at about 23.5 degrees. That tilt gives us our seasons, and more importantly, makes them predictable. But that tilt isn't fixed. It can wobble over time due to gravitational tugs from the sun and other planets. Without the moon's stabilizing influence, that wobble could become much more extreme, leading to dramatic shifts in climate and potentially rendering much of the planet uninhabitable. Imagine an Earth where the poles could shift wildly, causing massive ice ages or scorching deserts to appear seemingly at random. Not exactly ideal for nurturing complex life. The moon acts like a cosmic anchor, keeping Earth's tilt relatively stable over billions of years, providing the consistent climate necessary for evolution to unfold. Now, think about the tides. The moon's gravity is the primary driver of tides on Earth, creating the ebb and flow of the oceans that have shaped coastlines and ecosystems for eons. But the tides may have also played a crucial role in the origin of life itself. Scientists theorize that life may have originated in tidal pools, those shallow, nutrient environments that are alternately submerged and exposed. The moon's gravitational pull would have created a rhythmic cycle of wetting and drying, concentrating organic molecules and promoting the chemical reactions necessary for the emergence of life. Without the moon, the tides would be much weaker, reducing the chances of life getting started in the first place. Beyond climate and tides, the moon may have also played a crucial role in protecting Earth from asteroid impacts. The moon acts as a kind of cosmic shield, intercepting asteroids and comets that might otherwise strike Earth, potentially causing catastrophic damage to life. While it's impossible to know for sure how many impacts the moon has prevented, it's likely that it has made a significant contribution to Earth's long-term habitability. The frequency of impacts in the early solar system was much higher than today. The moon may have prevented enough to allow for long-term stability of simple life forms. This is, of course, a theoretical exercise to determine how unique the circumstances of Earth's success has been. All of these factors, combined with the unique way that our moon formed in the first place, may have conspired to make Earth an exceptionally rare planet, one that is uniquely suited for complex life to flourish. The giant impact hypothesis, which suggests that the moon formed from the debris of a collision between Earth and another planet-sized object, is itself a highly improbable event. The conditions had to be just right for the impact to occur, for the right amount of material to be ejected into orbit, and for that material to coalesce into a stable moon. The moon is not just any moon, but a moon formed in a specific way at a specific time, all contributing to Earth's unique status. If any of these conditions had been different, Earth might be a very different place today. A planet without stable seasons, without tides, and without a protective shield against cosmic impacts. A planet that may never have given rise to complex life. The rare Earth hypothesis is just that, a hypothesis, and as we explore more of our solar system and other planetary systems beyond, we will learn more about the conditions for life to arise. We could also find out if these conditions are common or truly rare. But for now, it's a reminder of the delicate balance of factors that have made life on Earth possible. It's a reminder of just how lucky we are to have a stable climate, a protective moon, and the unique combination of circumstances that have allowed us to thrive. The moon, in this sense, is not just a beautiful object in the night sky, but a testament to the improbable journey of life on Earth, and a reminder of how precious and fragile our place in the universe truly is. Next time you look up at the moon, take a moment to reflect on this unlikely story. Consider how different the world might be without its stabilizing presence, and appreciate the delicate balance of factors that have made life on Earth possible. In a vast and turbulent cosmos, we are incredibly fortunate to have a partner that has kept our world steady, watched over us from above, and helped us become the beings we are today. It's one of the reasons why we should protect what we have and continue to reach for understanding. A quiet thank you to an ancient light in the sky. The moon, our celestial neighbor, more than just a source of light in the night sky. It's a key player in maintaining the stability of our planet's climate, ensuring conditions suitable for the continuation of life on Earth. It is the protector and stabilizer. Without our moon, the world, as we know it, would likely be unrecognizable. The moon plays a huge role in stabilizing Earth's axial tilt. You might be asking, what exactly is axial tilt? Earth spins on an axis, an imaginary line running through the north and south poles. And that axis is tilted at an angle of about 23.5 degrees relative to our orbit around the Sun. This tilt is what gives us our seasons. As Earth orbits the Sun, different parts of our planet receive more direct sunlight at different times of the year. When the northern hemisphere is tilted toward the Sun, it experiences summer, while the southern hemisphere experiences winter, and vice versa. But what happens if that axial tilt isn't stable? What if it wobbled dramatically over time? Without the moon's gravitational influence, that's exactly what would happen. Earth's axis would swing wildly, leading to drastic changes in climate. Some periods could see extreme seasonal variations, while others might have no seasons at all. Imagine a world where the poles point directly at the Sun for months on end, creating tropical conditions in the Arctic, followed by periods of intense cold and darkness. Not exactly ideal for stable ecosystems or human civilization. The moon acts as a stabilizer, its gravitational pull keeping Earth's axial tilt within a relatively narrow range. This stability allows for predictable seasons and a more consistent climate over long periods of time, crucial for the evolution and survival of life. Now, let's shift our focus to the Earth's climate stability. The Moon plays a crucial role in regulating Earth's climate. The Moon's gravitational pull generates tides, which not only shape coastlines, but also influence ocean currents. These currents act as global conveyor belts, distributing heat around the planet and moderating temperatures. Without the Moon, these currents would be weaker, leading to more extreme temperature variations and potentially disrupting weather patterns. Consider early Earth billions of years ago. Tidal pools created by the Moon's gravitational pull acted as nature's chemistry labs. These pools provided environments where molecules could concentrate, dry out, and react, potentially leading to the formation of complex organic compounds, the building blocks of life. Without the Moon, these tidal pools might not have formed, or at least not in the same way, potentially delaying or altering the course of life's origins. Even after life emerged, tides continued to influence it. Marine animals evolved to feed, migrate, and reproduce in sync with tidal rhythms. The stronger lunar tides have played an important role in the evolution and sustainability of life. These lunar tides have aided in shaping the oceans and the origin of life as we know it. What about Earth's climate? Well, without the gravitational pull, our climate may have faced disastrous changes that were uninhabitable for species. It's safe to say our climate is safe in the Moon's hands. Some scientists theorize the Earth would be in a snowball effect if the axial tilt and climate weren't stabilized. The Earth would be frozen and uninhabitable for any species. It is truly remarkable how much the Moon plays in our daily lives. Even though it seems far away and silent, it silently protects us. It maintains the balance in our climate, all while keeping the axial tilt in place. The evolution of life has relied on the presence of our Moon, the constant body, the nightlight, our partner, and all throughout time. The evolution of species wouldn't be the same without it. This steady climate has led to all species evolving and adapting to the changes in environment. Our ancestors have relied on the Moon's patterns to travel, harvest, and build civilizations. There is so much we owe to our Moon and the influence it has created for our civilization. The Moon is the silent architect, silently helping create life and balance, one rotation and one tide at a time. We need to appreciate and be thankful for our silent protector and supporter, the Moon. It is constantly guarding our planet from dangerous collisions. Even if it does receive some damage, it is still fighting for us. For billions of years, we've been lucky enough to have this incredible and essential companion. It has watched us grow, create, cry, and build, It has constantly been there for us, and as a planet, we should acknowledge the moon's contributions to life and society. The moon's steady presence, a reassuring constant in a vast and ever-changing universe, has allowed life on Earth to flourish in ways we are still only beginning to fully understand. So, the next time you gaze up at the moon on a clear night, take a moment to appreciate its vital role in keeping our planet habitable. Without it, the Earth would likely be a much wilder, less stable, and far less hospitable place for life as we know it. The moon's role in maintaining our planet's delicate balance should not be underestimated, as our beautiful Earth would not be the same without it. Now, let's dive into a fascinating piece of the lunar story, its influence on evolution specifically. How its tides, transitions, and biological clocks helped shape the life here on Earth. Evolution, as we know, isn't a sprint. It's a marathon, a slow dance across eons, where the environment constantly whispers new steps. And in this cosmic choreography, the moon has been a persistent, if subtle, dance partner. Think back to the primordial soup. This isn't just a metaphor. It's where many scientists believe life's first tentative steps took place. The early Earth was a cauldron of chemical potential, but it needed a gentle nudge, a rhythmic stirring, to coax those molecules into something more complex. Enter the tides, driven largely by the moon's gravitational pull. These weren't the gentle, lapping waves we see on a modern beach. The moon was much closer then, exerting a far stronger gravitational influence. Imagine tides surging across vast coastal plains, flooding shallow pools with nutrient-rich waters, then receding, leaving behind concentrated solutions simmering under the sun's energy. It's in these tidal pools, these ancient chemical crucibles, that life may have gained its first momentum. The tidal cycle offered a regular, predictable rhythm. Compounds would concentrate as water evaporated. Bonds would form under the sun's heat, and then the returning tide would wash in fresh ingredients, cooling the mixture and setting the stage for the next round of reactions. Over countless cycles, this push and pull, this ebb and flow, could have facilitated the formation of complex molecules, the building blocks of life itself. The energy of the sun and lightning, and the protective buffer of water, and the concentration of molecules made complex molecules from simple components. The moon provided a persistent, gentle, repeating cycle, perfect to help form these complex molecules. But the moon's influence extends far beyond the chemical origins of life. Tides created unique environments. Imagine a world without strong tides. The shallow coastal zones would be far less dynamic, lacking the concentrated and diluted chemistry. The environments that did exist would be less hospitable as life became more complex. the moon continued to play a role, particularly in the intertidal zones. Those regions alternately submerged and exposed by the tides. These zones are harsh, demanding environments, requiring organisms to adapt to constant fluctuations in temperature, salinity, and moisture. Creatures that could thrive in these conditions were inherently adaptable, which may have accelerated the pace of evolution. Consider the transition from water to land. This wasn't a sudden leap, but a gradual process spanning millions of years. Some ancient fish developed stronger fins, not for swimming faster, but for propping themselves up in shallow, oxygen-poor pools. Others evolved primitive lungs to gulp air when water levels dropped. Eventually, some of these creatures found that venturing onto land, even temporarily, offered new advantages. The intertidal zones, shaped by lunar tides, provided a training ground for these early land pioneers. The moon, by orchestrating the ebb and flow of the sea, constantly presented opportunities for organisms to adapt to drier conditions. Those that succeeded could venture a little further each generation, eventually leading to the colonization of land. The influence doesn't stop there. Think about the biological clocks that govern so much of life on Earth. Many marine species synchronize their reproduction with the lunar cycle, or use the moonlight at certain times. Coral reefs, for example, often spawn in mass events timed to the full moon, releasing clouds of eggs and sperm into the water in a spectacular display of synchronicity. The precise timing maximizes the chances of fertilization and ensures that the offspring drift into waters teeming with nutrients. These species depend on repeating lunar patterns and evolved in ways that work directly with those rhythms. What would these species even look like if they didn't have those lunar cycles to work with? Even some terrestrial animals, like sea turtles, rely on the moon's light to guide their behavior. Female turtles come ashore to lay their eggs on beaches during specific lunar phases, and the hatchlings use the moon's reflection on the ocean to orient themselves toward the sea. It is a light for direction and a compass to stay safe. These behaviors, honed over millennia, demonstrate just how deeply the lunar cycle is woven into the fabric of life. There's also the fascinating possibility that the moon's influence extended to the development of cognitive abilities. The consistent and predictable nature of lunar cycles could have served as an early form of timekeeping for our ancestors. Recognizing patterns in the moon's phases may have spurred the development of memory, anticipation, and abstract thinking. A world without the moon could well have made human intelligence itself more of a challenge. Imagine a group of early humans tracking the moon's phases and associating them with seasonal changes, animal migrations, or tidal patterns. This ability to connect events in time and space is a key step in the development of symbolic thought, which is the foundation of language, culture, and science. As you think about those early humans, you might also consider what their world would be like without the moon. Would they have created languages based on long repeating cycles? Now, let's be clear. The moon is not solely responsible for the origin and evolution of life. Natural selection is a complex process with countless contributing factors. But the moon's persistent influence, its gentle gravitational tug, has shaped our planet in ways that have fostered life's development, pushing the ocean back and forth, concentrating molecules for success, providing stability, and giving evolution the time to work with all the pieces over countless years. The tides, the transitions, the biological clocks, and perhaps even the seeds of human intelligence, all may bear the subtle imprint of our silent, celestial companion. It's a reminder that even the most distant and seemingly passive forces can have profound consequences on the course of life. A gentle breath that slowly and quietly changes the course of life here on Earth. Let's turn our gaze now to the moon's less celebrated, yet undeniably important role, acting as Earth's cosmic shield. It's a bit like having a big brother who occasionally takes the hit for you. Only in this case, the hit is a multi-ton asteroid hurtling through space. Now, it's essential to say right up front that the moon isn't some impenetrable force field. It doesn't deflect everything heading our way. And it certainly doesn't completely eliminate the risk of Earth getting smacked by a space rock. However, by virtue of its location and its sheer rocky presence, it does take a significant number of hits that might otherwise be aimed at us. Think of it this way: Earth and the moon are traveling through space together, sharing the same orbital neighborhood. Space, as vast as it is, isn't entirely empty. There's a lot of cosmic debris floating around: asteroids, comets, meteoroids, remnants from the solar system's formation, and fragments from long-ago collisions. All of this material is moving at tremendous speeds, and occasionally some of it wanders a little too close. Now, imagine Earth as a slightly smaller target and the moon as a slightly larger one, positioned a short distance away. While Earth's gravity is stronger, pulling in a greater share of nearby objects, the moon still occupies a substantial amount of space in Earth's vicinity. Any object on a collision course with our general neighborhood has a chance of hitting the moon first. Each crater on the lunar surface represents a cosmic bullet dodged, a potential earth-shattering impact averted. The moon, lacking an atmosphere, doesn't have the benefit of burning up these incoming projectiles. Earth's atmosphere acts like a protective blanket, incinerating smaller objects before they even reach the surface. The moon, however, stands naked against the storm of space debris, absorbing every impact directly. This is why the moon's surface is so heavily cratered. It's a record of all the cosmic collisions it has endured over billions of years. Each one is a silent testament to the moon's role as a cosmic buffer. Now, let's think about the size and frequency of these impacts. Most of the objects that hit the moon are relatively small, ranging from dust grains to pebbles to larger rocks. Earth's atmosphere deals with most of these kinds of objects anyway. The real concern is the larger asteroids and comets, the ones that could cause significant damage if they were to strike our planet. It's these bigger objects that the moon potentially protects us from. Scientists estimate that the moon reduces the number of large impacts on Earth by a certain percentage, although the exact number is difficult to determine. What is more certain is that the consequences of even a single large impact are so great. Consider the dinosaur extinction event linked to a large asteroid impact in the Yucatan Peninsula. This wasn't just about dinosaurs. It was a planetary scale catastrophe that reshaped life on Earth. Events like that could be less frequent if the moon takes a few hits that could have caused extinction-level events. It's not just about the direct impacts either. Large collisions can also cause secondary effects like ejecta, material thrown into space by the force of the impact. Some of this ejecta could then rain down on Earth, causing further damage. By taking the initial hit, the moon reduces the amount of ejecta that reaches our planet. In effect, it's lessening the force of the blow. The moon itself offers a peek at its rough neighborhood. The far side of the moon, shielded from Earth, actually shows an even greater saturation of craters. The Aitken Basin, the massive crater on its south pole, is a permanent reminder that our skies are not empty, and the moon stands as an intermediary now. While the moon is helpful, we should not overstate its protective capabilities. Earth gets hit by space rocks all the time. Most of them are small enough to burn up in the atmosphere, creating shooting stars that light up the night sky. Larger objects occasionally make it through, creating impact craters that can be seen around the world. Barringer Crater in Arizona, for example, is a stunning reminder of just how powerful these impacts can be. The point is that the moon doesn't eliminate the risk of asteroid impacts entirely. It's more like a partial shield, a supplemental layer of defense in a solar system that can be a pretty hazardous neighborhood. If one thinks of it as cosmic roulette with extinction, the moon only helps to remove a few more spaces of doom. Don't see a lot of active bombardment events in history, and life has sustained on our planet for nearly 4 billion years. We can thank the moon for simply being there. There's also something deeply poetic about this relationship. The moon, born from a collision itself, has been absorbing collisions ever since, quietly protecting the planet from which it came. It is a constant reminder that everything is connected, and that even the most distant celestial bodies can play a role in our survival. So, the next time you look up at the moon, admire its silvery glow, and think about its beauty. Remember also its silent, steadfast work as Earth's cosmic protector, taking a few hits so that we might live a little longer under its light. Let's turn our attention now to a realm where the moon isn't just a silent observer, but an active participant in our journey beyond. Earth, from the first tentative rockets aimed at the stars to ambitious plans for lunar colonies, the moon has been a constant source of inspiration, a stepping stone to the cosmos, and a destination worthy of our greatest dreams. The story of the moon in space exploration is, in many ways, the story of humanity's relentless curiosity. Long before we knew what the moon was made of, long before we could even imagine walking on its surface, it was the destination of our imaginations. Ancient astronomers charted its course, poets filled its light with longing, and storytellers wove tales of fantastical journeys to its silvery surface. But it wasn't until the 20th century that those dreams began to take shape in steel and fire. The space race, born out of Cold War rivalry, propelled the moon from the realm of dreams into the arena of scientific and technological possibility. The Soviet Union's launch of Sputnik in 1957 sent shockwaves around the world, igniting a fierce competition to conquer the final frontier. The United States, determined to assert its technological dominance, set its sights on the moon. President John F. Kennedy's bold declaration in 1961, committing the nation to landing a man on the moon before the end of the decade, was a rallying cry, a call to action that galvanized scientists, engineers, and an entire generation of dreamers. The Apollo program was an extraordinary feat of engineering and human endeavor. It wasn't just about building rockets and spacecraft. It was about pushing the boundaries of what was thought possible. It was about inventing new technologies, solving unprecedented challenges, and training a new breed of explorers. And on July 20th, 1969, that dream became a reality. As Neil Armstrong took that first small step onto the lunar surface, he carried the weight of human history with him, a testament to our endless thirst for exploration. The Apollo missions weren't just about planting a flag and collecting a few rocks. They were about scientific discovery. The lunar samples brought back by the astronauts provided invaluable insights into the moon's formation, its composition, and its history. We learned that the moon and Earth share a common origin. Forged in the crucible of a cataclysmic collision billions of years ago, we discovered that the moon is a geological time capsule preserving a record of the early solar system that's been largely erased on Earth. But perhaps the most profound discovery of the Apollo missions was the perspective they gave us on our own planet. From the moon's desolate landscape, Earth appeared as a fragile blue marble, a vibrant oasis of life suspended in the vast darkness of space. This iconic image, the blue marble, sparked a renewed sense of environmental awareness and a deeper appreciation for the interconnectedness of all life on Earth. After the Apollo program ended in 1972, the moon faded somewhat from the spotlight, but it never disappeared entirely. Robotic missions continued to explore its surface, mapping its craters, analyzing its soil, and searching for signs of water, ice. And in recent years, interest in the moon has surged once again, driven by the discovery of water ice in permanently shadowed craters near the lunar poles. This frozen water represents a potential treasure trove, a valuable resource that could be used to sustain future lunar settlements. It could be melted for drinking water, split into oxygen for breathing, and even used to create rocket fuel for missions deeper into the solar system. The moon, once seen as a desolate and barren world, is now being viewed as a potential stepping stone to the stars. Several nations and private companies are now planning ambitious missions to the moon, ranging from robotic landers and rovers to human outposts and lunar bases. NASA's Artemis program, named after the Greek goddess of the moon, aims to return astronauts to the lunar surface by the mid-2020s, including the first woman and the first person of color. This time, the goal isn't just to visit, but to stay, to establish a long-term presence on the moon, and to use it as a training ground for future missions to Mars and beyond. The moon offers a unique environment for scientific research. Its lack of an atmosphere provides a clear view of the universe, making it an ideal location for telescopes and astronomical observatories. Its low gravity and abundant sunlight could be harnessed for solar power and resource extraction. And its proximity to Earth makes it an accessible destination for testing new technologies and developing the skills needed for deep space exploration. But the moon is also more than just a scientific laboratory or a resource-rich outpost. It is a reminder of our shared history, a symbol of our boundless curiosity, and a testament to our ability to overcome seemingly insurmountable challenges. As we venture back to the moon and begin to build a future among the stars, let us carry with us the spirit of exploration, the spirit of collaboration, and the spirit of reverence for this quiet, ever-present companion that has guided our dreams since the dawn of time. It's a future that, once again, shines softly and brilliantly in our imaginations. Imagine for a moment that our familiar moon, no trace, one night it's there, casting its silvery glow, and the next, nothing. What would happen to our world? What would the consequences be if we lost the moon? It's a question that delves into the very essence of our planet's stability, climate, and even the course of evolution. In the immediate aftermath, the most obvious change would be the night sky. Gone would be the soft, comforting light of the full moon, replaced by a deeper, more complete darkness. Stars would appear brighter, more numerous, but the familiar presence, the celestial anchor we've known since the dawn of humanity, would be missing. It would be a change felt in our bones, a primal sense of loss. But the absence of the moon would be far more than just an aesthetic disappointment. Its disappearance would trigger a cascade of environmental changes, starting with the tides. See, the moon's gravitational pull is the primary driver of our ocean tides. Without it, tides wouldn't disappear entirely. The sun still exerts some influence, but they would be drastically reduced. Perhaps only a third of their current strength. Coastal ecosystems, so intricately linked to the ebb and flow of the tides, would be utterly transformed. Tidal zones, those vibrant, dynamic regions where land and sea meet, would shrink, altering habitats for countless species. Many marine animals whose life cycles are synchronized with tidal rhythms would struggle to adapt. Think of coral spawning events timed with lunar cycles, or the migrations of shorebirds that follow the receding tides. These ancient patterns would be disrupted, perhaps irrevocably, but the most profound changes would occur on a much grander scale, affecting the very stability of our planet. The moon plays a crucial role in stabilizing Earth's axial tilt. Our planet spins on its axis, and that axis is tilted at about 23.5 degrees. This tilt is what gives us our seasons. Without the moon, Earth's axial tilt would wobble dramatically. Over time, it's like a spinning top that's starting to slow down and wobble. It's still spinning, but its angle keeps shifting unpredictably. That would be Earth. Instead of gentle, reliable seasons, we might experience wild swings. Some periods could see no seasons at all, while others could bring unbearable extremes. Imagine an Earth where the poles tilt so far that they point directly at the sun, creating tropical conditions at what we now call the Arctic, and later swing back the other way into icy darkness. These aren't changes that would occur over a few years, but over decades, centuries, or even millennia. But the long-term effects on Earth's climate and habitability would be devastating. The moon's disappearance would also affect Earth's rotation. The moon has been gradually slowing Earth's spin through a process called tidal friction. When Earth was young, a day might have lasted only 5 or 6 hours. The moon's gravitational tug has steadily stretched that out to the 24-hour day we experience. Now, without the moon, that slowing effect would be greatly reduced. Our planet might still be spinning much faster with much shorter days. Imagine living on a planet where the sun rises and sets every 6 hours. Our internal clocks, our circadian rhythms, might have developed in a completely different way. Everything from metabolism to sleep to the very way we experience time could be unfamiliar. And what about the psychological impact? For millennia, humans have looked up at the moon and found comfort, mystery, and inspiration. It has lit the way for travelers, marked the passage of time, and filled poetry with metaphors both elegant and cheesy. Remove the moon, and entire mythologies unravel. No lunar calendars, no moon festivals, no werewolves. Love songs would be a little less romantic. Literature would lose one of its most enduring symbols. But even more practically, humans would have lost one of their first and most reliable timekeepers, long before wristwatches or phone screens. Early humans tracked time by observing the moon's phases. A complete lunar cycle from new moon to full and back again takes about 29.5 days, conveniently close to a calendar month. This regularity helped ancient people plan agriculture, rituals, and travel. Without it, timekeeping would have been much trickier in early civilizations. The moon served as a cosmic reminder that yes, things do run in cycles, that there is order even in the dark. And, of course, the nights would be much darker. It's hard to overstate just how much moonlight matters when you don't have streetlights, flashlights, or glowing screens. Before artificial lighting, the full moon illuminated paths, fields, forests, and faces. It gave hunters and travelers an advantage, shaped behavior in nocturnal animals, and even influenced crime rates and sleep patterns in human communities. Without the moon, the night would feel much more complete in its darkness, less alive, somehow. A little colder, a little more alone. In a way, losing the moon would be like losing a part of ourselves. It's a reminder of our deep connection to the cosmos, of our reliance on the natural world, and of the delicate balance that sustains life on our planet. And so, let's turn our gaze toward the far future, a time so distant it barely registers on the human imagination. What awaits the Earth and Moon in those unfathomable epochs? Well, like any good story, it all comes down to relationships. Mainly, the complex gravitational dance between the Earth, the Moon, and the Sun, as we've discussed. The Moon is gradually drifting away from Earth, a process fueled by tidal interactions. It's a slow, stately retreat, But what are the long-term implications? Will the moon eventually break free entirely, becoming a wanderer in the cosmic sea? The answer, likely, is no. While the moon is receding, the Earth and Sun will eventually play bigger roles in determining its fate. The Sun, our star, is also evolving. Over billions of years, it will steadily grow brighter, warmer, and larger. This gradual increase in solar luminosity will have profound effects on Earth, eventually leading to the evaporation of our oceans and the stripping away of our atmosphere. As the Sun expands into a red giant, it will engulf the inner planets, including Mercury and Venus. Earth's fate is less certain. Some models suggest our planet will be swallowed whole. Others propose that it will be scorched but spared. Moon, however, might very well survive, depending on its distance from Earth at that point. The moon could either be consumed along with our planet or cast adrift into a wider orbit. A celestial castaway orbiting a dying star. It is the most likely scenario, especially with its outward spiraling trajectory, that it will be safely but distantly orbiting what is left of Earth and the now gigantic red giant Sun. This will be a brief reprieve in the long story of the universe. Now, even if the moon manages to avoid being swallowed by the Sun's red giant phase, it will still face an uncertain future, because as the Sun expends all its fuel, it will become an incredibly dense yet small white dwarf. This object will still hold the gravity to hold the moon, but the Sun's death throes will push the moon to the edge of the solar system. It will drift in the cold and darkness and relative peace of the outer solar system. The Earth will be long gone, but the moon will endure. For an even more long-term view of our moon, we would consider the heat death of the universe. Even this will not ultimately destroy the structure of our solar system. It will merely plunge into total dark and cold. Atoms will still exist, but without heat or light, they will be nothing more than husks. Long after the Sun has faded, the Earth turned to ash and the oceans boiled away. That silent celestial dance continues, but at a lower temperature. But before we get too caught up in cosmic endings, let's consider a few more earthly possibilities. Even if Earth avoids being consumed by the Sun, it may become uninhabitable long before. As the Sun brightens, our planet could enter a runaway greenhouse effect. The oceans would evaporate. The atmosphere would fill with steam. Earth would transform into a scorching, hellish world, reminiscent of Venus. In this scenario, the moon would continue its slow retreat, a silent witness to Earth's slow demise. Even more realistically, over billions of years, tidal locking could occur. Currently, the moon is tidally locked to Earth, which means we always see the same face. Earth is not tidally locked to the moon, though this would occur with enough time. In a hypothetical, tidally locked Earth-Moon system, Earth's rotation would slow dramatically, and the length of a day could approach 47 of our current days. The sun would take half a year to rise, and another half a year to set, and to make things more complicated, axial tilt may not be present on such a tidally locked Earth. The moon may even one day meet another object out in the vastness of space and be flung into a different solar system entirely. But this outcome is so exceedingly unlikely as to be nearly impossible. It is far more likely the moon will be tidally locked to a dead Earth, orbiting the faint remains of our dying sun. But what is more important is the story. The moon has been with Earth since its infancy, a silent guardian and companion, witness to the rise and fall of countless species. Its future, whatever it may hold, will be a continuation of that story, a testament to the long, slow dance of gravity and time. It has given Earth so much, and all that Earth can offer it back in thanks is its silent company as the universe continues to evolve. Earth, and by extension, the moon, has already played its part in the narrative of the stars. They have no future to hold, but instead, the Earth and the moon have a past to relish. The Earth can now fade, and the moon drift away, and they can be comfortable knowing that they are survived by their legacy on the very real possibility of life. What a gift